Look, we're all hearing about the massive global shift to clean energy, right? It's literally one of the biggest projects humanity has ever taken on. But what you might not be hearing about are the huge, hidden hurdles lurking just beneath the surface. So today, we're going to break down two of the biggest ones.
All right, let's get right into it. We're going to look past the usual debates and focus on two challenges that honestly don't get talked about nearly enough. First, the wild unpredictability of our changing climate, and second, the absolutely insane demand for raw materials. And trust me, getting these right, that's the whole ballgame. It's what will decide if we succeed or fail.
Okay, first things first. To really wrap our heads around these challenges, you have to appreciate the sheer epic scale of what we're trying to do here. We're not just tweaking the old system. Nope, we're trying to build an entirely new one, pretty much from scratch by 2050.
So, the Energy Transitions Commission lays it out pretty clearly. The goal here isn't just to, sprinkle in a few more wind turbines. If you look at this, it shows we have to completely transform the entire system that powers our world. Everything. Our homes, our factories, all of it, in just a couple of decades.
So what does that actually look like in the real world? Well, take wind power. We need to take all the wind power capacity we have globally right now and multiply it by 15. 15. That is just a staggering amount of new stuff to build.
And if you thought that was wild, check out solar. The number there is even bigger. We're talking about a 25-fold increase in our current solar capacity. 25 times. It's a scale that's almost hard to wrap your head around.
And this transformation isn't just about the power grid. It's coming for our roads too. Right now, we've got about 25 million electric vehicles. By 2050, we need, wait for it, over 1.5 billion. That's a 60-fold increase. It means completely remaking transportation as we know it.
Okay, so here's the crucial point. When you build a system that depends so much on the sun and the wind, you're essentially making a massive bet on the weather. But what happens when the very climate change we're trying to fight starts throwing us curveballs and making that weather totally unreliable?
We all get it, right? A coal plant can just keep chugging along 24/7. But a wind or solar farm? It's always going to have its ups and downs. The real problem is that climate change itself is making those natural ups and downs way more extreme and a whole lot harder to predict. In Germany, they have this fantastic word for this very problem, Dunkelflaute. It literally translates to dark doldrums, and it's exactly what it sounds like. A long, dark, windless period, usually in winter, that can just cripple renewable energy production. It's the scenario that gives energy planners nightmares, forcing them to fire up fossil fuel plants just to keep the lights on.
And hey, this isn't just about wind and solar in Europe. This kind of volatility is popping up everywhere. We're seeing things like crazy low rainfall slashing hydropower output by more than half in places like Namibia and Sudan. And then on the flip side, you have Chile, where unexpected heavy rains caused an 80% surge in hydro production. Imagine trying to manage a grid with swings like that.
Okay, so that leads us right into the second huge challenge. And honestly, this one might be even more fundamental. It's a physical problem. Where on earth are we going to get all the actual stuff we need to build this clean energy future?
Yeah, that sleek, shiny future of EVs and elegant wind turbines, it doesn't just appear out of thin air. It starts right here, in a mine. And to build all that clean tech, we're going to need a mining boom on a scale that humanity has, frankly, never seen before.
This right here perfectly illustrates what experts call a demand shock. It's this sudden, massive spike in need. And for those key ingredients for things like batteries and electric motors, we're talking lithium, nickel, cobalt, the demand is just set to go through the roof, skyrocketing by 2050.
Now, to be clear, the issue isn't that we're going to run out of these minerals on planet Earth. Long term, there's enough. The real pinch, the real problem, is the next decade. Experts are warning that for a whole list of these critical materials, lithium, copper, cobalt, we're facing some serious supply gaps. We just can't ramp up the mining fast enough to hit those crucial 2030 goals.
So, okay, we've got an unpredictable climate messing with our power supply and a massive bottleneck for the materials we need to build everything. What do we do? Well, the answer isn't to hit the brakes. The answer is to get a whole lot smarter about how we do this. And the path forward really breaks down into three big ideas. We need to get smarter about prediction, smarter about how we use the materials we have, and smarter about how we source new ones.
So for that first part, smarter prediction. To fight back against that crazy weather volatility, that Dunkelflaute we talked about, we can use something called climate intelligence. It's basically using AI, massive data sets, and advanced forecasting to predict energy surpluses and shortages, not just days ahead, but months or even years in advance. That makes our grids way more proactive and resilient.
Next up, smarter use. This is huge. To take the pressure off all that mining, we have to get creative. We can design technologies that are way more efficient, like batteries that need less cobalt. And at the same time, we absolutely have to build a powerful recycling system. I mean, think about it. We're about to put millions of tons of these valuable materials into the world. We need to be ready to capture and reuse them.
And finally, smarter sourcing. Let's be real. More mining is gonna be necessary. There's just no way around it. So the key is to make sure that when we do it right. That means using the absolute best practices and having strong regulations to protect local communities and the environment from the worst impacts.
So when you step back and look at all of this, you start to realize something. This transition, it's about so much more than just swapping a coal plant for a solar farm. It is a fundamental shift in the entire logic of how we power our world.
And this slide just lays it out so perfectly. Think about it. The old fossil fuel system, it's all about constant consumption. You extract fuel, you burn it, and poof, it's gone forever. But the new clean energy system, it's based on an upfront investment. You extract the materials once to build things like turbines and batteries, and then you use and reuse and recycle those materials for decades. It's a totally different mindset.
So yeah, the initial build-out is incredibly resource-intensive, no doubt about it. But the system we create on the other side is fundamentally more sustainable. We shift from a system of constant extraction and burning to one of building, using, and then reusing. It's basically creating a circular economy for our entire energy system.
So in the end, it really comes down to this. We have the resources. We have the roadmap. The success of this whole thing doesn't really hinge on a lack of minerals in the ground or a lack of sunshine. The real question is a human one. Can we innovate and can we collaborate on a global scale, fast enough to pull this off?